The northern lights, also known as the Aurora borealis, are a captivating natural light display that paints the night sky with mesmerizing colors and patterns. This celestial spectacle has enchanted humanity for centuries, inspiring awe and wonder. But what exactly are the northern lights and what causes this extraordinary phenomenon? It all starts with the sun, our giant ball of hot gas that's always throwing out charged particles, primarily electrons and protons. We call this stream of particles the solar wind. When this wind reaches Earth, it bumps into our planet's magnetic field, the magnetosphere, which is like a big shield protecting us. But some of these particles sneak through the shield, especially near the north and south poles. Earth's magnetic field lines converge at the poles, creating a funnel-like effect. As the charged particles from the solar wind are drawn towards the poles, they collide with atoms and molecules in Earth's upper atmosphere. These collisions excite the atoms, causing them to release energy in the form of light. This emitted light is what we see as the northern lights. The National Oceanic and Atmospheric Administration, NOAA, issued a G4 alert indicating a severe storm for the first time since 2005. A severe geomagnetic storm hit Earth's magnetic field starting on Friday, May 10, 2024. This storm was significant enough to make the northern lights visible to most of Michigan, a rare occurrence for the region and other areas as far as Arkansas. The northern lights aren't just one color. They can be green, pink, red, yellow, blue, even purple. It's like a rainbow dancing across the sky. The different colors come from different types of atoms getting excited and the height where it all happens. For example, green auroras typically appear at lower altitudes, while red auroras occur at higher altitudes. The most common color you'll see is a pale green, made by oxygen atoms about 60 miles above us. Nitrogen molecules produce blue and purple hues. The northern lights are most commonly visible in high-latitude regions around the Arctic Circle. This includes countries like Canada, Alaska, Greenland, Iceland, Norway, Sweden, Finland, and Russia. However, during periods of intense solar activity, the aurora can sometimes be seen further south, even reaching as far as the northern United States and Europe. The best time to see the northern lights is during the winter months when the nights are long and dark. The optimal viewing time is usually between 10 p.m. and 2 a.m. local time. Additionally, clear skies and minimal light pollution are essential for the best viewing experience. The northern lights are not static. They constantly move and change shape, creating a breathtaking spectacle. They often appear as shimmering curtains, dancing ribbons, or swirling spirals that illuminate the entire sky. The intensity and duration of the display can vary, lasting from a few minutes to several hours. Scientists use a scale known as the KP index to measure the intensity of geomagnetic activity, which directly influences the visibility of the aurora. The KP index ranges from 0 to 9, with higher numbers indicating stronger activity and a greater chance of seeing the aurora at lower latitudes. The northern lights have held cultural and spiritual significance for many indigenous communities living in the Arctic regions. These communities have developed myths and legends around the aurora. As technology advances, scientists are developing new tools and techniques to study the northern lights. Ground-based observatories, satellites, and sounding rockets are all being used to collect data on the aurora and the solar wind. This research is helping us to better understand the interactions between the sun and Earth, as well as the potential impacts of space weather on our planet. The study of the northern lights is not only important for scientific understanding, but also has practical applications. For example, space weather can disrupt communication systems, power grids, and satellite operations. By understanding the processes behind the aurora, scientists can develop better forecasting models and mitigation strategies to minimize the impact of space weather events. Today, people still come from all over the world to see this natural wonder. The Northern Lights continue to inspire awe and wonder in people from all walks of life. Their ethereal beauty and ever-changing patterns create a sense of mystery and connection to the universe. Whether you are a scientist studying the aurora's complex mechanisms or a traveler gazing up at the dancing lights, the aurora borealis is a reminder of the vastness and wonder of our cosmos. In recent years, there has been a growing interest in astrotourism, with people from all over the world flocking to see the Northern Lights. This surge in popularity has led to the development of new infrastructure and services in remote areas, providing economic benefits to local communities. The Northern Lights have become a significant driver of tourism in recent years, generating substantial revenue for countries located in the high-latitude regions of the Northern Hemisphere. While exact figures are difficult to pinpoint, available data indicates a substantial economic impact. For example, in the Nordic countries, accommodation stays in cities within the Arctic Circle increased by 217% between 2009 and 2016, with airport traffic and tourism expenditure growing by roughly 280%. In Finland, revenue of Lapland hotels saw a 129% increase from 2017 to 2022, and Finnair increased their capacity to Lapland by 20% to meet the growing demand. In Norway, 32% of foreign tourists in the 2019 winter season were specifically Northern Lights tourists. The global polar travel market was valued at $830.5 million USD in 2022 and is projected to reach $2003.6 million by 2031, with a compound annual growth rate of 10.28%. The years 2024 and 2025 may see a particular boost due to the sun approaching the peak of its cycle, further intensifying the Northern Lights displays. These figures demonstrate the growing allure of the Northern Lights as a tourist attraction, contributing significantly to the economies of countries like Canada, Alaska, Greenland, Iceland, Norway, Sweden, Finland, and Russia. Beyond the direct economic impact, the Northern Lights tourism also supports local communities by creating jobs and boosting ancillary industries such as hospitality, transportation, and retail. This phenomenon highlights the potential of sustainable tourism centered around natural wonders, showcasing how responsible practices can benefit both the environment and local economies. The southern counterpart to the aurora borealis, known as the aurora australis or southern lights, occurs in the high-latitude regions around the Antarctic Circle. Both of these lights are a beautiful sight that you have to see at least once in your lifetime. In the next video, we will cover the southern lights in more detail. Thank you for watching. If you've learned something, press the like button to support the channel so we can bring you more videos, and share to educate the next person. See you in the next one. Don't forget to press the red subscribe button as well. It's free.